Last couple of days, what we've been working with is we've been working with fractions and radicals. And if you've missed a couple of days, or you missed one of those days, I've got some review problems here to start. In the first one, here we're going to be adding and subtracting terms with radicals. And 6 square root of 5, we can't do anything to. And 2 times the square root of 10, we can't do anything to. Square root of 25, can we take the square root of 25? It's 5. And really, what I should have done first is, according to order of operations, I should have multiplied those two together. But we can do them at the same time, taking the square root of 25 and multiplying this. When we do multiply this, it's going to be 3 times the square root of 10, and it's going to be minus. It's like -1 times 3, and then the square root of 2 times the square root of 5. So once we have that simplified, we can add these like terms together. We don't have anything alike with 6 radical 5. We do have 2 square root of 10 and 3 square root of 10, and in fact they're both negative. We get minus 5 square root of 10, and then we have plus 5. On letter B, we have division on that first term. Remember when we divide, that we're going to divide those two. 28 divided by 4 is 7. Square root of 18 divided by square root of 3 is square root of 6. Over here in the next term, the square root of 24, we need to simplify it. And it's 4 times 6, which is 2 times 2. And 2 times 3. And when we simplify a radical, we're looking for 2 of the same value. Take out 1. We end up with 2. And then we have a single 2 and a single 3. 2 times 3 is 6. And to finish this particular problem, now we see that we do have like terms because we have square root of 6 in both. When we add the coefficients. 7 plus 2 is 9. Then the next day we started adding, subtracting, multiplying, dividing fractions. As we look at letter C here, I'm going to rewrite this problem as 2/3 and leave a little bit of space plus 1/4. And we need to find a common denominator whenever we add or subtract. And 3 times 4 is 12, which is going to be our common denominator. Well, what we had to do with this one is we took 3 times 4 to give us 12. And if we multiply the bottom of the fraction by 4, we have to multiply the top of the fraction by 4 as well, which is a fancy form of 1. And then 2 times 4 is 8. Same kind of idea with the 1/4. 4 times 3 is 12. If we multiply the bottom by 3, then we need to multiply the top by 3. And 1 times 3 is 3. Now that we have a common denominator, we can add these two together. All that we need to add is the numerator. 8 plus 3 is 11. Divided by 12. Again, adding and subtracting fractions, we have to find a common denominator. When we multiply, we don't have to find a common denominator. We're going to multiply the numerators, the tops of the fraction. We're going to multiply the denominators, the bottom of the fraction. 5 times 3 is 15. 2 times 5 is 10. And as we take a closer look at that fraction, what I hope we notice is that there is a number that goes into both 15 and 10. If we divide 15 by 5, and 10 divided by 5, we end up, 15 divided by 5 is 3, 10 divided by 5 is 2. Letter C. 2 divided by 1/7. Well, this is going to be 2 over 1. But when dividing, don't ask why, flip the second one and multiply. So it's 2 over 1 times 7 over 1. And 2 times 7 is 14. Now, we're going to put the fractions and the radicals together. You'll see this a lot if you take pre-calculus next year. And the principles using example 1 apply to all problems below. And the thing is, in pre-calculus, we can give you a calculator for problems like A, B, and C, but it doesn't help. You have to know the fundamentals of the fractions and the radicals to be able to do the problem. Hence what we've been doing for the last couple days. If we look at letter A, we're multiplying these two together. And when we multiply, we do not need a common denominator. We simply multiply the tops. Square root of 2 times square root of 8 is square root of 16. We multiply the bottoms. 3 times 2 is 6. Can we simplify the square root of 16? We can. It's 4. 6. And lastly, we need to ask ourselves, do we have any number that goes into both 4 and 6? And it's going to be the 2. So we're going to divide by 2 here, divide by 2 there, and when we finish this problem, we end up with 2/3. Multiplying. We multiply straight across. When we look at letter B here, it's going to be the square root of 3 times 7, which is just going to finish with 7 square root of 3. We like to write the coefficient first. The 7 is the coefficient. Down here in the denominator, 3 times 5 is 15. And that's all we can do to that problem. We multiply the tops, we multiply the bottoms. There's nothing that simplifies here. On letter C, one thing that you might want to do is you might want to put a 1 in front of the radical. You don't have to. Because when we multiply, we're still going to multiply the tops together and we're going to multiply the bottoms together. So it's 2 times negative 1 is negative 2. Square root of 5 times square root of 15 is square root of 75. 3 times 4 is 12. And now that we've done this, the thing to notice is that 2 and 12 can be simplified. 2 goes into 2 one time. 2 goes into 12 6 times. But we still are not done with this problem. Because what has to happen now is we need to simplify the square root of 75. And if you remember, I'm going to scoot this over a little bit. We multiplied 5 times 15 to get 75. If you pick 3 times 25, there's nothing wrong with that. So 5 times 15 is also 5 times 3. And what we're looking for are 2 of the same value to take out 1. 2 5s, take out 1. Now when we put that back in, it's negative 1 times 5 square root of 3 divided by 6. And lastly, negative 1 times 5 is negative 5 square root of 3 divided by 6. There's the multiplication with the radicals in it. Division, as we move on to our next ones here, division. When dividing, don't ask why, flip the second one and multiply. So on letter A, when dividing, don't ask why, flip the second one. So it's going to be the square root of 5 divided by 2 times 2 over 1. Then it turns into multiplication, which is we multiply the tops together, we multiply the bottoms together. We get 2 times the square root of 5 divided by 2. We can simplify a little bit more. The 2's cancel out. And if you prefer, 2 divided by 2 is 1. Or we don't have to write the 1. Those both mean the same thing. Fine if you write the 1, fine if you don't write the 1. But we do need to simplify. Notice that both those 2's were not in a radical. They were both outside, so to speak. So we can simplify those. Well, the particular concept that we're looking at here in this section is dividing. When dividing, don't ask why, flip the second one to multiply. This is 3 over 1. So it's going to be square root of 3 over 3. Flip the second one and multiply. Once again, we multiply the tops together, we multiply the bottoms together. Square root of 3 times 1 is square root of 3. 3 times 3 is 9. That's all we can do to that problem. 3 is underneath the square root and 9 is not. We cannot divide those because 1 is underneath the square root and 1 is not. Letter C. When dividing, don't ask why. Flip the second one and multiply. Square root of 2 over 2 times square root of 5 over 5. Flip the second one, and now we're going to multiply. Square root of 2 times square root of 5 is square root of 10. 2 times 5 is 10. Again, that is all we can do on this particular problem because 110 is underneath the square root and 110 is not. As we flip our paper over to finish, adding and subtracting. We need to have a common denominator when we add or subtract. And luckily, on this first problem, we have a common denominator already. We don't have to find it. So when we finish this problem, all that needs to happen is we're going to say square root of 2 plus the square root of 3, all divided by 5. We cannot combine the square root of 2 and the square root of 3 because the numbers underneath the radicals, known as radicands, are not the same. The only way we could add those together is if we had the same value in the square root. When we take a look at letter B, we need to find the common denominator. And some of you are going to say 18, and that's fine. It'll be a little bit more work. But if you can find the least common denominator, it's going to be a little bit less work. And if you look at the denominators, ask yourself, will one of those denominators go into the other denominator evenly? More specifically, will 3 go into 6 evenly? And because that answer is yes, our common denominator is 6. And I need to write the problem again. I want to leave a little bit of space here. Square root of 7, one more time. Square root of 7 divided by 6, leave a little bit of space, plus 1/3. And again, 3 goes into 6 evenly, so our common denominator, in fact our least common denominator in this case, is 6. And what we did is we multiplied 6 by 1. So we were going to multiply the square root of 7 times 1. It's not even a fancy form of 1 when we write that 1 over 1. But over here in the 1/3, we multiply 3 times 2 to get 6. And whatever we multiply the bottom, we have to multiply the top. 1 times 2, that's 2. And then we can finish this problem. We've got a common denominator now. It's going to be the square root of 7 plus 2 divided by 6. If you're thinking, can I cancel the 2 6? The answer is no. We need to have some multiple of 2 attached to the square root of 7 in order to be able to cancel it. So in this problem, square root of 7 is a part, the 2 is a part, and the 6 is a part. All 3 parts need to be divisible by the same value. And we do not have that on this particular problem. Letter C. Square root of 6 divided by 5 minus the square root of 6 divided by 3. Once again, when we write this here, for adding and subtracting, we have to find a common denominator. So I'm going to write the square root of 6 over 5, leave a little space, minus the square root of 6 over 3. And we need to find the common denominator. Well, 5 times 3 is 15. Common denominator is 15. And then let's see if we can figure out our fancy form of 1. Well, 5 times 3 is 15. So the square root of 6 times 3. This would be 3 times the square root of 6. Same kind of idea here for this second fraction. 3 times 5 is 15. So square root of 6 times 5. Whatever we multiply the bottom by, we multiply the top by. The 5 over 5 is the fancy form of 1. And we have 5 times the square root of 6. And some of you will see this step before me, but when I started, I wrote 3 radical 6 minus 5 radical 6 divided by 15. But as I look closer there, and you probably saw it before me, both of these terms have the square root of 6 in them. These are like terms here. We can combine those. They both have the square root of 6 in them. So 3 minus 5 is negative 2 square root of 6 divided by 15. And lastly, 1 minus the square root of 2 over 2. Remember, that 1 is 1 over 1. So when we write this, I'm going to write 1 over 1, leave a little space, minus the square root of 2 over 2. And we want to find our common denominator. And 1 times 2 is 2. And then we can use our fancy form of 1. And it's 1 times 2. Give us 2. So here is 1 times 2. We have 2 over 2. On our second fraction, it's 2 times 1, which gives us 2. So the square root of 2 times 1 is the square root of 2. And to finish, then we have a common denominator. We have 2 minus the square root of 2, all divided by 2. Remember, keep the denominator. And lastly, if you're thinking that you can cancel out something on here, we cannot. Again, there's 3 parts. There's the 2, there's the square root of 2, and there's the 2 in the denominator. All 3 of those values need to be divisible by 2. And we don't have any number in front of the square root, so we cannot cancel anything out.